Thank you all for attending. As you can see from the PowerPoint, it's Tecplot, but in essence, we are looking at how we use HES output in Tecplot. So it's mainly we start with like some talks about HES output, then we switch to Tecplot and show you how to open files, look at data coming out from HES in Tecplot. So yeah, presentation will be divided into 4 partitions. Part 1 will be introduction, talking about HES output, what kind of HES output, and what data you will get out, and how you control the data coming out of HES. So what kind of HES plot that we can plot on a time series, and how to edit, how to show time series plot. Part 3 will be looking at 2D and 3D HES outputs, and part 4 will be some advanced functions. After part 2 and after part 3, I will give like a small tutorial. So we'll go through the presentation slides showing how the steps are done. And then by the end of part 2 and the end of part 3, we'll do like a tutorial where we show you on how to use Tecplot with HES. So we'll start with part 1, which is HES outputs. We'll look at types of HES outputs, some of the HES output commands that will export data, and how to control HES output before running HES, and how to control HES output before running Hsplot and preplot. So if you are not familiar with HES, HES has 3 steps when you run. You have something called grok, which is a preprocessor which reads your input file and write it in a way that HES can read. Then you have your HES, which is the solver, which reads and give you like the outputs. And the third part is something called Hsplot, and Hsplot will read HES output and write it in a format that Tecplot can read. Okay, so what are the types of output? Here we have something called a time series output, and this is familiar. Like you have first column, which is time, and you have other variables depending on what type of command you are using. So we have hydrographs. Hydrographs is when you add an observation point for surface water flow. And if you look at the top one, the top figure here, it's a sample of output. It shows you the title of the observation hydrograph. It gives you what kind of variables it's showing and a zone. You have wells too, and wells, you can see wells in the time series and wells in block format. It's depending on which type of commands you are using in HGS. So if you are using observation point, it will give you a time series. If you are adding a well point, it give you a block format. So for wells, you can see, I think this is the second figure is from wells. It show you like also title and show you some kind of like outputs. You have also the water balance. The water balance is default. Like whenever you run HES, it will give you like a water balance file. You don't have to add any command in HES. Soil balance give you the volume of water in each domain you have in the model. This one you have to add a command to let it work. Block format is wells, but in a different way. So the difference between well in time series and when in wells in block formats is if in time series you assign a certain point as your well. In block format, you assign several points in HES as your well, and when it give you the output, it give you at each of these points, and this is why it will write it in a block format. And then you have some binary output file. This binary output file you won't be able to see unless you run Hsplot. And it will give you a file for each domain you have. You have a BM domain, which is for porous media. You have overland domain, you have channel domain, and so on. When you run Hsplot, it will turn it into a .dat file that you can read in Tecplot. If you run something called preplot, it will generate a .plt file. You can also read in Tecplot. The only difference is that .plt file is a bit quicker to load. Okay, so what kind of variables will you see in your files? Usually it's like the output for a file will become different based on domains. So let's see you have an observation point. This observation point is at the surface. You have a porous media domain, it will report only values at porous media. You have a surface domain, it will report surface domain too. So if you look here, you will have, if you look at this file was in a model that has both porous media domain and overland domain. So you will have your head, pressure, saturation, discharge. And if it doesn't have any notation, this is the default one, and the default one is for porous media. H node, P node, Q node. If you have an O, it refers to the second domain in this case, which is overland domain, and so on. If you have HF, PF, QF, you have a fracture domain, and you have some domains if you are running a density-driven flow. If you have transpiration turned on and evaporation turned on, you will get transpiration and evaporation values at this certain point, and so on. So based on your domains, we have overland, fracture, channel, well, dual continuum, and tile drain. So this is all the domains that we have in HES. And in definition, H is for head, total head, P pressure head, S saturation, Q is a discharge, T is time, and V is velocity. Okay, we're looking at some of the key commands. So for surface domain, one of the key command is you want to capture flow going through streams. So a main command is set hydrograph nodes, and you select a node in a fence. If you have your stream running in one direction, you set up like a fence. A fence will include at least 3 nodes, and this will be perpendicular on your stream, and it will capture flow going through the stream and give you the values of fluxes going through this fence. You have make observation point, and this one can work for both porous media and OLF. And you pick a point on your mesh and you assign a make observation point, and this point will report to the variables that we showed on the last slide. Make interpolated observation point. In this case, what if your well or the area where you want to observe values at doesn't fall on a node in your mesh? It falls in between. So you put your X and Y and Z location and make interpolated observation point. And in this case, HES will look at all the closest, calculate the values at the exact point interpolated from these nodes. You have make observation well, and this one is this is the one I was talking about. This one is different because in this one you can select more than one node, and it will create a file that will give you all the heads and other values with depth. You have a soil water balance command. This one will give you this list. So will give you at a certain time the amount of water in soil, which is the unsaturated part, the amount of water in the groundwater, which is the saturated part, the top 10 centimeters, the top 1 meter, the total porous media, all the water in your porous media domain, and all the water in your surface domain. This is really useful when you are looking at a long simulation and you want to see if your domain is drying or wetting. This is an example of the hydrographs. So you selected a node. This node is a fence perpendicular to your stream. It records your fluxes, and the name will be prefixes your grok name. So it will take your grok name and add it here, and whatever name you give your function will be added here. And then in this case, you can see like it will report time, flow in the surface domain, flow in the porous media domain, just below the hydrograph, and then the total, which is the summation of surface and porous media flow. Make observation point. You pick up a point on your mesh, and it will. This will be the output file name, grok name, your well name .dat, and it show you like all these parameters, which is head, pressures, saturation, discharge for both porous media and overland. It will show you X, Y, and Z. This is the location of your node. So just in case, like let's say you have make your observation point and you added X, Y, and Z, but the X, Y, and Z that you added doesn't fall on a node on your mesh. In this case, it will select the closest one to it and then assign it. So you can look at X, Y, and Z, and you can figure out which node it's selected. And it actually gives you the node number if you want to look by node number to see which node was assigned in this case. Make interpolated observation point. This is the one we talked about. In this case, it's not going to assign it to the closest node. It's going to look at all the closest node and interpolate the values. And will show you, I think we'll show you the same file. If you have transport problem where you have concentration, you will see that it will add concentration values to your observation file or to your output file. Make observation well. This is the one that you choose a start point and end point, and it will select all the nodes in between. So in this case, you can see here that if you count, you have a bunch of depth. So we selected all these nodes at different depth, and it will report the head. And this is good if you can't locate exactly where your well is, like you know your screen, but or you don't have an exact location of your screen, and you want to report all the values with depth, and you want to see which one will match your observation data. You can use this command. Block format, I don't think that this format can be read in Tecplot, so you have to process it first before running it on Tecplot. Okay, soil water balance file, we talked about this one, and it will give you soil, groundwater, and so on columns. This one is a Tecplot format, should be fine. You have fluid volume for choosing nodes. Same as soil water balance, but you don't want to look at your whole model. You want to concentrate your values into a specific area of interest that you want to look at in this case. We have some commands that will give you extra data. Mesh to Tecplot. So this one, you run grok and you want to see your mesh before you start running HGS and Hsplot. So you have some command. These are commands that will run on grok and give you .dat files that you can take it and open it in Tecplot before running HGS and Hsplot, which is a good thing if you want to, in this case, look at your mesh before running HGS, make sure that everything you assigned looks right. You can look at your K values, you can look at your porosity, ET zones. So these commands are nice, like for pre-check before you're running HGS. Let's say you assign K, you mistakenly somehow assign K in the wrong way. So you can open the file before running HGS, look at your K, values, make sure that everything is okay before going to the next step. And you have other commands, but this one, I think this one needs HES to be running, and this one will report your fluxes for certain nodes or for a slice and so on. Second thing, you wanna control your HES. You are not interested in some outputs and you're interested on certain outputs. You don't want HES to run by default. So HES will report everything or like save every output in your model. It's good, but in some cases, let's say you're running a long simulation and you are saving, let's say, daily. So if you leave HES to save all outputs, your simulation folder will be huge. So in this case, you wanna let HES know that just save what I need. And in this case, you open a file called output_variable.control and open it before running HES. You'll find a list of all HES output. And the default is yes. So head for porous media is yes, so it will report. Head for dual continuum is no, don't report this one. Head for overland flow, no, don't report this one. And so on. You will go through the whole list and choose yes or no, depending on which output you want. If you leave it if you leave it for default, it will report everything. The second file is .plot.control. This file is this one. And what you need is that when you run Hsplot, it will read all HES output, turn it into .dat file. What if you have all the output, but you only want to look at certain variables? In this case, you come here, and in this case, like it's an exclamation mark, comment. So you come here and comment all the variables that it's all commented as default. What you want to do is uncomment the one that you don't want to show. So let's say you don't want to show the porous media heads. So you uncommented, and then it will say no porous media heads. It's not going to take the output from HES and show it in Hsplot. If you change these files and you want a default one, just delete them and HES will write a default file. What if you run Hsplot and you are showing everything? You didn't uncomment any of the variable, but you want to limit Hsplot to show certain area or show certain time. You are saving for a long period, but you are interested in like 6 months of this period. You have your whole model, but you are interested only on looking at maybe a lake or a river or somewhere of interest. So if you want to truncate your porous media domain, it's also in the same file, which is plot.control. You can see SNW. This is a model. It will, in your case, SNW will be your model name, your grok file name. You go to truncate PM domain and you add an xmin, xmax, ymin, ymax, zmin, zmax, and it will show you only the area of interest you are looking at. You can truncate by layer. So you give it x and y, min and max, and you give it your bottom layer and top layer, and it's only going to create a file for this area. Or you can truncate time domain. You can give it starting time and end time, and to only give you output for this period. And all of this is for all of this truncate is for ease, or like if you have like a bigger domain, lots of output, and it takes lots of time to open and work with. In this case, you could truncate, and it will be smaller file and easier to open and play with. This is a sample. I truncate. This is a dual example that we are going to work on today, and I want to truncate this area to look at. It was a random area, like cut from 40 to 60 in X and cut from 4 to 8 in Y. minus 100 and 100. I give it like a really big number. I want to keep all the layers, so I give it like a out of range values, and it cuts this area only. And then you can see when it cuts, it will follow an element. It can't cut through an element, so it will choose the line through the element as close as possible to your elements. Okay, Tecplot format. Let's say that this is how HES will report output file, but let's say you have an observation data and you want to have it in the same format as HES. For some reasons I'm gonna talk about later. This is how you can write your observation data. You can write variables. It doesn't have to be a bunch of these variables. It can be time and flow, and that's it. And you give it a zone name and a title. And if it's like two variables, you will have two columns, which is time and, let's say, observation flow. Tecplot can still read CSV files. It's fine too, but the .dat file give you more options. If we came through it, I will say in details. Yeah, something else, like for people who has a newer version of HES or newer releases of HES, we add now auxiliary data to our output. So let's say you have a file, you want to open it, and you don't remember where you run it, when you run it, or which units did you use. You don't have to go back to your grok file and search for it. HES will output now all this data. So you can see it in the file itself, or if you open Tecplot and look at auxiliary data, it will show you simulation time, when the simulation was started, or I think when the simulation is ended in this case, and which HGS version are you using, and what's the units are using, length, mass, time, and so on. And you can go to the auxiliary data and search by variable, and each of these variables will show you what kind of units are these data, which give you more ease to go through this part. Okay, going to part 2, which is a 2D plots time series. We look at how to upload data to Tecplot. Mapping style. So through mapping style, you can define which variable you want to look for, what kind of plot you want to look at. You want to add secondary plots, modify your axes, add line legend, all this kind of like Excel type stuff that you do it in Excel. You can do it also in here. More stuff that you can do that Excel can do will be blanking. You probe to get your data, and then you can look at your data set information and data spreadsheet to get more information about your data. We'll go in details for each one of these. When you open Tecplot, it will look something like that. Here is the probe menu. Here is the active frame. This is where you show your time series. And here is the plot menu. And if you have pages, it will show down here. And I guess frames also, you can show frames here. And then you have your toolbar on the top here. How to load data, we'll show all of this in the tutorial, but it's easy. Like you have a button. If you go back, this one, the uploading button, you press on it and choose a file, and it will give you a default option. Usually it's right, but you can make sure that it's right. So .dat file from HES will be a Tecplot data loader. And if you are opening a CSV file, it's a spreadsheet loader. You load your data, and then you go through mapping style. And when you load the data, it will show you all the variables with time. So you have your surface domain, porous media, total, channel leak, and so on. And then you can choose which one to show and so on. Second thing is what kind of plot? Do you want to show a line plot? Do you want to show a scattered plot? Do you want to show two plots with different axes? You want to show, like in this case, you want to show the surface on one axis and the channel on a different axis, and so on. So we'll give you like some way to modify your variables and how plot look like, and it's through lines, symbols, and so on. Go through this one also through the tutorial. Second thing is modifying axes. So let's say you don't like the X and Y axis name, you want to add your own name. In this case, you can go through axes and you choose which axis you want to modify. And in this case, we want to modify the title, so we're going through axes. We have an X axis and Y axis. These are the main axes, and then you have X2 and so on, like to X5. You can have 4 more auxiliary axes in this case. You can show grid lines. You can choose your spacing for the X and Y axis. And value blanking. So let's say you have your hydrograph. You have a hydrograph flow, and after a certain time, the flow becomes 0, and you don't want to cramp your view of like the important part in this part, and you want to like remove the non-important part and concentrate on this one. So the next time when you like refresh your view, this part will take the whole width of the figure. So you can do something called value blanking. And what it does, you go and choose which variable you want to blank, what condition you want to blank at, and give it a value. Can be a variable or a constant, and make it active. And you can blank up to 8 things. So eight different criteria to blank values. So in this case, what we did is that we said like at 1.65 to the power 8, we don't want to show the rest. So we choose for time, whatever greater than 1.65 to the power 8, just remove it from the plot. Second thing is probe data. So you have your figure and you want to get the exact value at a certain point. How can you probe? Like give you lots of options. You can press a button, probe at, and on the screen, you come on the screen and press, and will give you the value, or by x-axis or y-axis in this case, because like our bot had only x and y. So you choose which axis you want to get flow at, or what flow happened and which time. It can be either way, or by something called index. So each when you load your data, it's in the form of rows and columns. Each row has a certain index. So the first row of your data has an index of 1, second row has an index of 2, and so on. So if you know which point you want to look at, you go, instead of position, you go through index and give it the value of index, and it will show you what the data is. Dataset information. So you can go through dataset information, and let's say you have a file open or several files open. I want to see which file is the first file, which file is the second file, and so on. You go through your dataset information and will show you all the data you uploaded to your Tecplot file. And in this case, we had only one file, which is hydrograph.h1. This is the only file that were open. And if you go through zone variable information, the zone name was h1, and it gives you all the variables within this zone. You can you can assume that your zone is your file. So each file you open will be a new zone. So if you talk at a zone or a file that you open, it should be interchangeable. So we have one file opened, and this file has this bunch of variables. And give you some information too, like how many columns, how many indices, what kind of data, minimum and maximum range for the data. And if you go through data spreadsheet, it will give you the data as a table. So you can go through your zones, or in this case, your files, and switch through it, and you can look at your indices, your time, and what kind of data that you have for each of these files. This file is useful too if you want to turn this data into Excel file. You can Control A, select all this file, copy, and paste it in your Excel file if you want to do something in Excel. Okay. We'll also talk about altering data. So let's say you have certain data and you want to do some calculations. You can go through data, alter, specify equation. So let's say that your data is in second, and you are looking at a hydrograph, and it's too hard to figure out where you fall within a day, or where you fall within a month, or where you fall within a year. And you want to switch the data into hourly, daily, or whatever kind of data, or like you want to show. Or you have data and you want to do some calculation, add two variables, subtract two variables, get differences, and so on. So all this stuff can be done in specify equations. The main four types of equation is you can do a calculation on axes. So what you are telling Tecplot here is that take your x-axis, and the new x-axis will be the old x-axis divided by 360. So we turned the data from seconds into hour. Just in case, like in this case, like x-axis is time. You wanna do calculation by creating a new variable. So the new variable, you have this kind of parentheses equal to two more variables. Like so these variables is already within the output. So if we go back, so I'm gonna add surface to total to create a new variable. And the new variable will be variable number 8, and it will show new here. So what I'm going to do is I will create a new variable. I call it new. It's surface total. What if you don't wanna write the variable name, you can write the variable number. So in this case, I'm adding variable 2 to variable 4. If you want to know which variable, you go back to variable information. Variable 2 is surface, variable 4 is total. So it's the same. I can write it this way, or I can write it this way. I can scale one of the variables. So in this case, what if I scale my variable 2 by multiplying 1.1 and override the old variable? So you can update your variables. You can work between different zones. Different zones means different files. So what if you have two different files? You have the water balance file and you have the soil file, and you do want to do calculation between both files. So the number between these parentheses in this case is the zone number. So I want to take the variable which is surface in the first zone, and I want to do calculation on it. In this case, I want to put this value in a new variable. Okay. Yeah, here is an example. What we did is I went to specify equation. I specified the new x-axis in this case to equal the old x-axis divided by 60, divided by 60, divided by 60, divided by 24. So I turned seconds into days. It gives you better understanding here. So if you go back to the file before modification, you look at these seconds and you have no idea what's going on. like, is this a day, 2, whatever? But here it's way easier. You can look here, our simulation was for 30 days. Flow started on the first day. It peaked at after like almost 2 days, and then the flow went down, and in 10 days we have no flow, and it went to almost 0. We had here, it show you which zone or which file, and so we are doing this calculation for this file only. So whatever file you choose is the file that you are going to do the calculation on. In this case, we created a new variable. We had surface flow, we had channel flow, we added both of them. We called the output as flow, so we have a new variable. You can put a new variable and show it here. Here we want to see the difference. We have 2 hydrographs, 2 files, 2 zones, all seem the same. And we want to see what the difference in flow between hydrograph 1 and hydrograph number 5. And what you do is that, since it's a different zone, we'll tell it read the channel flow in the first file, read the channel flow in the second file, subtract both, create a new variable, which is the flow difference. And then you can show the flow difference. In this case, you can see like between hydrograph 1 and hydrograph 5, there was a difference in flow about 9 cubic meter per second. If you want to show more than one plot, there's something called tile frame and frame linking. So tile frame, you add each one of these plots is called frame in Tecplot. So in this case, we have 4 frames. We want to show these frames like side by side, stacked on top of each other, stacked side by side. We want to show the first one in a bigger format and then the rest as a smaller plots. You can choose which one, like you add your frames and then go to frame, tile frame, and then choose between these 4. And let's say you tiled your frames like that, and you want to zoom in to this part. But when you zoom into this part, you want Hsplot by default to zoom to the same time in all the rest of the 3 files. There is something called frame linking. Whatever you change on this one or you move in this one will happen in the other ones. And you have frame size and position, solution time, X, Y, and axes, X, Y position, and you can also link planking too. Perform integration. So in this case, you have your hydrograph. Let's say one of these hydrographs. You want to see how much flow that happened through this rainfall event, or what was the average flow that happened through this rainfall event, and so on. You can go here, do scalar integration. Scalar integration will give you the volume, and you choose which one. In this case, I want to look at channel flow and indices. In this case, let's say you have your hydrograph starting here, the rainfall events ends around here, but you get like some tiny flow until it vanishes. But I want to look at the flooding period only. I want to look at from 0 time, and I want to end it here. I want to only calculate for this part. In this case, I go to the index and I choose which index. I have the time here that I want to end, and I can go and choose what index is this one, go and write from what index to what index, choose it here, choose the value, press integrate, and it will give you the volume. And in this case, the volume of flow in hydrograph 1 was 1.5 million, and the volume of flow for hydrograph number 5 was 832,000 cubic meter. And it will give you the total by default. Simulation versus observe. What if you have HGS output and you have your observation file, and you want to show your observation versus your simulated? You want to see how good your simulation look like. And in this case, you load your HGS output. And I'm going to show the same example in the tutorial, and then you load your observation. And when you load your observation, it gives you like 3 options. Do you want to overwrite? You want to remove the old data and reset style, or you want to keep the style and remove the data, or you want to keep the style and keep the data. So in this case, like if I choose any of the other option, it will remove the line here, which is simulated HGS output. I want to keep it so I can show the observed data on top, and I check and see my observation versus my simulated, how far my simulation is from observed. And you can output. So you create your, let's say this is your final result. You are happy with it and you want to export it as an image so you can use it in your report or your presentation. So you can export the frame as PNG, JPG, and BMP. And you can only export a frame, a work area, or all frames. I'm not sure what the difference between work area and all frames. It's, for me, it seems the same, but maybe it has some differences. But let's say you go back here, you want to choose a frame. So in this case, if you look at this frame, this is the one that highlighted. So if I want to export this one only, I will choose current frame. Or I can go and select this one and choose current frame and it will export this one only. If I want to export all 4 of them as one file, I'll choose a workspace or all frames. You can enter a width if you find that the image is a bit pixelated and you want to add more pixels to it. You can add your own width to it. And then you can save your file. You finish your file and want to save it. You did like lots of calculations and all this nice stuff, and you want to keep it for later. You can save it as a .lay, which is a linked file, or .lpk. And the difference between these two is that the .lay file, when you open it, it will search for your input file. And it will search in the last location it found it. If it didn't find it, it will crash. So you need to keep your .lay file and all your outputs that you used in the same location to open it. The .lpk file is a standalone file. It will save all what you did, plus it will save all your input file inside it. So you can move it everywhere, different machines, you can run it from everywhere. The only problem with the .lpk file, it's bigger size. So in some cases, it's huge that you want to only keep the .lay file. Part 2. Before we go to part 2, we will start a tutorial. I have okay, let's do the question later, but let's go through a tutorial. Time series. Okay, not these files. Okay. Okay, so in this case, I have hydrograph number 1, and I have observations for hydrograph number 1. I have hydrograph number 5, and have an X hydrograph. This hydrograph I'm only going to show to you. This is from the new HES releases. If you open this file, it has the new auxiliary data. But most of the work we will do in hydrograph 1 and 5. So let's open Tecplot and start the tutorial. Okay, I can load data to Tecplot by 2 ways. I can load it or drag and drop. The only problem with drag and drop is every time you do it, it will overwrite the files. You can do it for your first file, but for the rest of the files, you have to upload it. So let's in this case drag and drop this file. Okay, so I dragged and dropped this file. What we'll do, it will show the first variable it reads. So if I open mapping style in this case, how many variable I loaded in this from this file or from this zone, I have 6 variables. Usually it will show you the first one in the list, so it will mark the first one on. Okay, so this is my first file, which is the surface flow. I have porous media flow. I have total, which is surface and porous media. I have channel flow, channel leak, and channel total. So channel total is a summation of channel and channel leak. Okay, and the default figure here is the line plot. If you see here, it's line. If you look at symbols, it's turned off, bars and error bars. Okay, so this is one of the hydrograph. I want to show porous media flow. It's a flow below the channel, moving below the channel. So I'm expecting it's really tiny values. I turn it on. I can't see anything. If I press this button and move it up, it's almost 0, and it's actually like a bit negative. So we have like a tiny flow moving backward. So in this case, we can actually ignore porous media, but channel flow should be the main flow. So we have a rainfall event. You would expect most of the flow to run within a channel and a tiny bit to run on the surface. And then the surface in this case is what flooded from the channel. I added this one and I can see the top of the channel. So you can go through view and press data fit, and will fit your data. And you can see you have about 14 cubic meter per second going through channel. You have about a bit more than 4.5 cubic meter moving on the surface domain. So you have tiny bit of flooding happening during this rainfall event. Okay, most probably I will need both of them. So let's say I have my flow going through this area. So I want to see the summation of flow. In this case, we will do what we showed before, which is called data specify equation. I go through alter specify equation. I want to add a new variable. So I only opened one file in this case, which is h1. I want to create a new one, which in this case I will call it flow, and it will equal to surface. What if you are trying to run your do your equation, but you don't remember what the name of the variable or the syntax, like you can press dataset information and open it on the side here, and then you can see you have like surface flow. So if you want to write it correctly and you don't want to know, and you don't know exactly the spelling or the syntax for your writing, you can do it this way. So I want to add the surface flow, which is variable 2, to channel flow, which is variable 5. So I'll do it this way. And if I run it, I created a new variable. Let's say like it went successfully. So I run it this way, and it added as its variable here. So I can go and let's say I create a new map, and in this case I will add flow and plot view data fit. So I have my total flow, my surface flow, and my channel flow. Let's say I don't wanna show the other two. I already added flow here. I will name the variable here and close this one. So I have my total flow. Next, let's say I want to make the graph look a bit neat. You have your plot axes, and you can show the grid, major grid line, minor grid line in this case, can change the colors for the grid lines, make it a bit darker or a bit less darker, and so on. You can go to y-axis and do the same. And if you want to close the plot, you can go into line and show grid line, and then you close your plot. Okay. Next thing, let's say I want to add my observation data to the same graph. So I can go, and in this case, load, and choose my observation data. In this case, should be spreadsheet loader, should be fine. I want to append, and it's telling me that the variables in this file are different from these variables. So I'll tell it to add all these variables, and okay. I will create a new map. In this case, I want to show the time for observation and the flow for observation, and it's the second file, which is the observation file. Press OK, and it added the observation. In this case, the observation is point data. You can't interpolate between these two data. So you go and choose symbols. I want to change the observation from line plot to scatter plot. So I choose symbol. In this case, it will turn both of them into symbols. I go to mapping style. I choose symbols, and I turn it off for flow, and I keep it for the observation. And I go to lines, and I turn the line for observation. So now the observation points are looking at like points, scatter plot, and simulated data look like a line. I can change the symbol. I want to make it a bit smaller, and I want to fill it with same as line color, and so on. So I have my observed and my simulated. I go through definition, and it's change the names for simulated to be simulated, and for observed to be observed. And I can go here and plot line legend and show a line legend. And in this case, I will show you which one was observed and which one is simulated. Okay, I'm interested in this part of the plot, so we'll do the value blanking. You go through, I think, anime plots and do value blanking. And I want to terminate my graph here at, let's say, 1.65 to the power 8. So I choose at time is greater than 1.65 to the power 8. Press active here and active here, and it will remove whatever higher. And if I'm in this case, I go to view and data fit. I will show me only the parts I'm interested at. Let's say I want to do some calculation to check the error between observed and simulated. I can use the function prop@. You can press a button and it will give you a line, and then you can align it at exact point and press a point, and will show you how much the flow in the simulated or observed. You can do it by axes. You press at prop@, and then you can go to data, spreadsheet, and choose the second file, which is observed data, the second zone. In this case, these are your time and these are your observation flow. So if you want to do it exactly at that time, let's say want to do it for this third point, can copy the time here, paste it here, and do prop. And when you do prop, you will see here that simulated flow was 15.3 and observed flow was 13 Same here. You can actually copy these values and paste it in Excel if you do want to do some calculation for error. Okay. Second thing we want to do is that we want to look at doing equations between different variables. So let's say you want to add a new frame. So in this case, I want to look at hydrograph 1 versus hydrograph 5. So I want to press this button, add a new frame here. I go to frame, tile frames, and let's say I want them stacked on top of each other. So this is my old file. My new file is here. I want to load both hydrograph 1 and hydrograph 5. So I have both of them. What it did is that it will draw the first variable in the first, for the first file or the first zone. Okay, in this case, what I want to show is I want to show channel flow and its time versus channel for hydrograph number 1. And I want to show the same one, the channel flow, but for hydrograph number 5. Press OK. Pause. You can press Control F. It's a shortcut to do like a data fit. So in this case, I have two hydrographs. This one was downstream, this one was upstream. And let's say in this case, I want to see how much flow occurred between these two hydrographs. How much water collected between these two hydrographs for the channel flow only. Should be easy. We go through data, alter, specify equation. And in this case, I want to do like maybe flow generated between these two hydrographs. It will equal to channel for the first zone minus channel for the second zone. Sorry. And compute. And I should have the flow difference. Can go to mapping style, create a new map. In this case, I want to see time with the flow generated between the two hydrographs. And the new variable will be assigned to both zones. So it doesn't matter which zone I choose. HES, sorry, Tecplot will create the new variable in both of the files. So it should be any file should be fine. And here I can see the new line. This is a flow difference. In this case, that was generated between the two hydrographs. Okay, I can link the two figures. So let's see, I wanna, because like since both of them has for the same site, and each time you wanna zoom to a certain plot, you want the same for the second plot. I can go frame linking, and let's say I wanna only link x-axis. So whenever I zoom to a certain time here, I will do the same for the bottom one. I'll choose the top hydrograph, so or the top frame. So this will be the main one. I will say I wanna link x-axis. In this case, apply for all zones and close. And you can see that there's the same time here. It is shown for the bottom plot too. If I zoom in to a certain time, let's say I zoom into the climbing limb in this case, it will do the same for the bottom one. So I can see in this case how much flow in hydrograph number 1, how much flow was observed, and if I look down here, how much flow difference occurred between the two stations at the same time. And you can do the same for, we can modify the axis here, show it. We can show line legend too. All what we did for the top plot, we can do it for the bottom plot. Something else here is you can go through lines. Let's say I choose this plot and you can change colors. So let's say I want to make this one different color. Can choose a color, can make the line thicker, even thicker. You can change type. So let's say I want to see the difference here as a dash line and thicker line. So you can change how the line look like. You can change the names for the x-axis and y-axis. So let's say you can go through data. Plot axis, and you can choose, let's say, the time in seconds. So I want to go through title. I want to add the time was in second. I can do that. Whenever you press someone else, it should show. So I have here time in second. Can do it for here too. Change the title and oh, sorry. Yeah, I did it for the wrong axis. Sorry. This one should be flow meter cube per second. The y-axis, the x-axis is the one that should be saying time in second. And I think we covered here all what we want to talk about for 2D plot, except one small thing is called the perform integration. So let's say you have your figure here, and let's say press Control F. You have your figure here. You want to you want it in volume. So we have here. You can here get how much flow generated between the two stations. What if you want to see how much total flow volume was generated between these two stations through the rainfall event? So in this case, I want to integrate for the flow generated. Okay, if I do the flow generated, it will do it for the whole time period. What if I want to calculate for this part only? So up to this point. So I press the index. It begin at 1 at the beginning. That should be good. Where it ends, I need to find the index. So you go through data. Cancel this one first. You go through data, spreadsheet. You want 1.64 to the power 8. So you scroll down. 1.645 to the power 8. Around the index is 294. So I go back here and I choose, I want to start at the beginning till the index of 294. Okay, and then integrate. I told you that the new variable will be written in both zone 1 and zone 2, which is what you see here. So you don't need both of them. One of them should be enough. So 639,000 cubic meter were generated between the two stations. Okay, let's say that this figure is nice. You want to generate an image. For this one, you can go file, export. PNG should be fine. Current frame should be fine. And you can look here. This is frame 1 and 2. The one highlighted here and the one highlighted here is the one chosen. I want to choose the current frame only. I want a high resolution, so I'll go like maybe 2000 and then press OK, and will ask me to write a name for the file. So let's say sim simulated versus observed, and save it. And it will save the image. If we go back to the folder, you can find it here. And I want to save this project file in case I want to continue later. I will say I will go File, Save Layout As, choose a .lay and say here hydrographs .lay and save it. Okay. We'll go through the part 2, which is displaying 2D and 3D geospatial data. How to upload 3D data, how to show the mesh. Shade is your volume. I think we have a question here. We'll go through the questions in after we finish part 2. It should be part 3. By the end of this part, we can actually look at questions and talk about it. We'll talk about uploading 3D data, mesh. You can just look at your mesh. Shade, it'll show you the volume of the model, like without any variables shown, like only like the 3D figure of it. Show contours, and then we can, within the contours, we can show variables and change colors, show legend, show contour lines, different contour lines, go through zone styles and show you how to change zone styles. Okay, we look here, it's exactly the same as the 2D. You have your same setup. It will show you more options here in the plot menu. It will show you simulation time because you can switch between different simulation times. You have isosurface, strip traces, slices, and so on. So the first thing we're going to show is when you look at the plot menu, you have mesh, contour, shade, vector, edge, and scatter. Usually we use the first 3, and sometimes the fourth one is useful too. Edge and scatter. Edge will show you like the edge, like it will show you lines around the edges of your model. Usually I don't use this one. Scattered, you hardly can see anything in a 3D domain if you choose scatter, but you can choose shade, which is this shape. You can look at the shape of your model. You can add mesh to your shade and it will look like this figure. You can hide mesh and add contour and it will show you different variables, whatever saved in your file, it will show it to you here. And it will show you at your solution time, and you can switch between different solution times. You have your zone style. So whenever you show one of these, you go through zone styles and start changing stuff. So in this case, I have a porous media's domain only that was loaded in the model. I'm showing contour, but contour had different options. You can have flood, primary value, and lines and flood. So flood is smoothed. So this is flood and this is primary values. So primary values, whatever was reported from HGS as a value for a certain mesh or certain cell, it will show here. But the problem is in the big picture, it doesn't look that good. If you smooth these results and show flood, it will look like that. So usually, rule of hand is if you want to show results, you want to show it as flood. If you want to show your input files, you want to show it as primary value, because you want to see exactly what you assign to your domain. And flood can come with lines. The only option, the options that you get with your line is that you can add numbers to these lines. So let's say you have your picture here, you have your legend on the side, you can read the numbers. What if you want to see an exact number here? So through the lines, you can press on the line and add a certain number. It's useful in some cases. However, usually flood and primary values is the one that I recommend. Okay. You go through surfaces. Tecplot, when it loads the shape, it will load the edges only. So whatever inside the model will be hollow. and it does that for ease. Like if it loads all the files, it will be hard to rotate the figure and move it and so on. So the default surface that Tecplot shows is a boundary cell only. But in some occasions, it's not enough. So let's say you did value blanking similar to what we did there. So you want to cut a certain part of the model. And if you have the boundary cell only, it will be the parts that you cut will be like exposed and you can see, you see like a hollow shape inside. Another option, if you are going to do blanking, is choose something called exposed cell. So when you blank, whatever exposed will show. You can show all cells, but super heavy to do, especially if you have a big model. Second thing is you want to play with your contour lines. Where you can do that, if we scroll back and you see contour here, if you press on the setting for contour, it will open this window. In top here, you choose your variable. So in this case, I want to show the total head. These are the levels that Tecplot is going to show. If I like it, that's fine. If I don't, I can set my own level, or I can manually add levels, or I can manually choose some of these levels and remove it. Second thing is what color map you wanna use. So you can go through different color maps, choose between them, and so on. Yeah, if we go through set level, you can find you can get exact and you can get approximate. You can divide it, you can distribute it as min and max number of levels, or min and max and delta, and exponential. In this case, let's say you have hydraulic conductivity, min and max and delta won't be nice. Exponential might be better. And the final tab here is legend. You can show the legend, you can hide it, you can make it vertical, horizontal, you can squeeze it, you can play with it, show headers and so on. So this is where you modify this part, the legend. You have slices too. So let's say you have, this is your 3D model and your K or your zones change inside and you want to see what's inside, like you want to cut it in slices and you want to see what's inside your model. Instead of like looking at the outside of it, you can choose slices, and slices can be done in X and Y axes. You can choose your own axes and can show more than slices. So in this case, I'm showing 3 slices in X plane, and I'm showing one slice in Z plane. You can animate slices. So you can show, this is good for your presentation. So if you want to start with a slice here and move it with time, like an animation till the end, so you can animate slices, you can show, so you can move it and look at changes in output or changes in the input data. You can have also isosurfaces. So isosurfaces, you want to see, let's say, where you have total saturation, like fully saturated areas, or like where pressure equal to 0 or whatever. Like you want to find an area with the same value. And in this case, you can assign it through slices. And in this case, I'm looking at the saturation, and I want to look at all the areas within the model that has a saturation of 95%. Probe at the data, the same as what we did in the time series. The only difference here is when you probe the 2D and 3D data, some of the values are nodal values and some of the values are elemental values. So variable values is nodal values. Cell values are elemental values. So let's say you probe and you press the button somewhere. Okay, and in this case, zone is an elemental value, and you are showing nodal value. In this case, it will interpolate elemental value to nodal values. So whenever you have a star, it means that this value is interpolated. If you want to see the accurate zone, you change into cell center. And when you change to cell center, the nodal values will have a star because now it's interpolated. Let's say that you have your 3D, but you want to see at a certain point what is the value. You probe it like that. Okay, how the values changes over time for the whole simulation. You do something called probe to create a time series. So you choose a point, you press on a point, and it will show you from the start of the simulation to the end of the simulation what was the values. And in this case, head, and you can see here that head was about like 3 meters at the start. You have a rainfall event, the head went up by about 10 centimeters quickly, and then like a slow rise till about like 12 centimeters, a rise of 12 centimeters, and it start dropping after the rainfall event was done. What if you want data across a line? So what if you want to look at head across the whole model? So you can draw a line in Tecplot, right click on the line and extract the values at this line. And then the new data will be called extracted points. And you can take the extracted points and plot it. In this case, I'm going to plot Y because like this is a Y axis, and I want to plot across this line. So across Y, I want to plot what was the head values at this line. So I can do it through extract points through a polyline. You can actually draw shapes. It doesn't have to be a line, but usually like I usually use like a line to see at a certain cross section what the values are. Okay, macros. I'm not going to go through this one, but what you do through macros is, let's say that you have something that you are going to repeat on several layout files for Tecplot. So you do it, you start with your first file, you load your files, and then you start recording, you do something, and then you stop recording, save the macro. And in this case, I opened a 3D, and then I start the macro, I draw a line, I extracted points, and then stop the macro. And then whenever I open a new file, I open the same macro, and what it will do is that it will draw the same line and extract the same points. So if I want to compare between two different simulations, I open the first one, draw a cross section, because it will be super hard to draw the same line on a different file. So when I draw it and extract the points, I save a macro and then open the new file, do the same, and then I have the same cross section through the model to compare before and after. And I can take the data and do like a time series plot for it. We have the same linking frame and editing frame. So if you have more than one frame, you can tile frames, you can link frames. 3D view is one new that we didn't use in time series, but we use it a lot in 3D plots. And you can show more than one domain. So you can have your forest media in one figure, and you have your overland in a different one, and you have your channel on a third one, and so on. So same thing as the time series. You tile your frame and then you link your frame, so you can have the same view in both. And then Same also, you can tile more than one frame. In this case, I'm tiling 4, and I'm showing 2 porous media, one showing the zones and one showing head, and I'm showing the head in the all left domain, and I'm showing zones of the all left domain. You can show time. So in this case, because you switch when you press play in Tecplot, you switch from one time to another. So sometimes you want to keep show the time, so you want to know which time are you looking at, and you come to text and add and solution time between brackets, and it will show you the solution time in seconds, because the simulation in this case we're in second. If you want to change it and you have like you can do like a delta, and it will show you let's say you are saving daily, so you can start with 0 days and 1 as a delta, and it's called time strands. It will be easier to show this one on the model itself, so we'll get this one later. And also you can show it as a date, so you can turn the seconds into days or dates. We'll show this one in the tutorial. Okay, and showing water as a flat surface. So I think this is okay. Yeah, we have 2 slides and then we start the second tutorial. So the first one is flat water surface. So what if you want to show something like that? You want to show your porous media domain, and you want to show a flat water showing where the water is covering your 3D domain. We start with 2 frames. One is surface domain and one is the porous media domain. For the surface domain, you want to show the areas where it was flooded, like the channel. So you do a value blanking, and the value blanking will be based on the water depth. So you choose areas that has water depth, and areas that is dry you want to hide. So I'm only showing here areas that was covered with water. And then the second thing is I want to take this frame and place it on top of this frame, exactly on top of this frame. So I do a frame linking, and I'm doing 3D view, solution time, and frame size and order. So I will put this one on top. But in this case, this is showing the head. I want to show it as a water surface. So I go through this frame, change the z-axis into head. I'm going to show it also through the tutorial. I think it's a bit hard to describe it here, but when you see it in the tutorial, it might be easier to understand. And the last thing is that you can create a video. So you go through your time steps and show how the water change, and you can add prop at a time series also to the picture. So it show you which time and a certain value in this case. Okay, so let's go to the second tutorial. So let's close this one. We already saved this one. Okay. So in this case, I want to add the Abdul example 2D and 3D. So I have 2 files. One file is the OLF domain and one file is the porous media domain. So let's say I load the porous media domain first. It will take some time. This is why we're talking about truncating the model and choosing variables. So even though this one is a small model, it will take some seconds to load. So imagine you have a huge model, how long it will take, especially if like it's a slow machine or something. So it show you like the limits of your model. If I choose contour, it will show you my contour. If I press mesh, it will show me my 3D mesh. If I hide contour and hide mesh, it will show me the shade. So the shade will show you your 3D model. You can look at it, make sure that, yeah, it's the right model, it loaded the right DM and so on. So this is the first step. You add your contour This is the second step, and you go through it. You add your mesh and look at your mesh. So it's an easy flip through. Okay, so in this case, let's say I want to show only the contour, and zone is my layers in the model. So in this case, I don't like how it show a range of zones. Zone should be like an integer, so I'm gonna go through details and change how it look by setting level, and I'm going through min, max, and delta. So I have 3 zones, so I will start with zone 1 as a minimum zone, zone 3 as my high zone, and then a delta of 1, and then okay. So I have my 3 zones here, zone 1, 2, and 3. So the model includes 3 layers. Let's move the zone down. In this case, the zone are shown, the contour is shown as flat, so it's smoothing the edges. I don't like that. Like I want to see exactly where my first zone start and where my second zone start and so on. So I go through my zone style, I go through contour, and I want, because this is an input file, I want to see the primary value. And if I press on it, it will change a bit, but it will give me like a sharp edge between first layer and second layer and third layer, which I prefer in the input file. Okay, so I have my porous media domain containing 3 zones. If I add mesh, I can zoom into the mesh and see how I divided my model. So if you look here, my top layer is divided into 4 layers, or 5 layers, and so on, and have like high discretization for the top, a bit lower discretization for the middle, and a lower discretization for the bottom. And if I look at the 2D, you can see that it's fine mesh in the middle where the stream occur, and coarser mesh away from the stream. So I'm adding more horizontal resolution at area of interest, and I'm adding more resolution to the top where most of like the actions happen. Can press plot, view data fit. I want to show you a good fit for the data. Gonna hide the mesh. I already looked at the mesh, so I want to look also at the surface domain. So I want to see how the surface domain was assigned. So what I'm going to do is that I'm going to create a new frame in this case. Okay, I'm going to go and do a frame, tile frames. I want to show them side by side. Okay. And for this one, I will choose a new frame. And what I'm going to do is I'm going to load the OLF data. The OLF by default will show as a 2D layer, but you can change it easily into a 3D layer. It should be the same, it should be the surface layer here. It showed a bit different because I think Tecplot do a different vertical exaggeration for the OLF domain. It's easy, you go through plot, axes. And if you look here, X and Y axis has an exaggeration of 1 versus about 35 for Z. And if I choose a porous media frame, it will show that it's 1, 1, and 1. So the only thing I'm going to do is here at the go and choose the same vertical exaggeration. So both sides will look similar here. I will go to the same contour and raise details, and the same happen here. Like I want to show zones as integer, so I want to do the same. So I'll go here and set zones, and have a minimum zone of 1 and maximum zone of 2 and a delta of 1, and I press OK. And same also for input files, I want to show it as a primary value. So this is how the OLF domain was assigned in HES. We have two different zones for the overland domain. This one is a river, is assigned as a river and will carry characteristics as a river, friction and so on. And the side ones can be maybe agriculture or forest or something different. It will carry different characteristics. Okay, so we have our two zones. This is the input file. What if I want to start to see, to look at output files, results? So let's say I choose zone 1 and I already looked at the input file. I can save this one, I can export it, I can change it, but I already looked at my input data, looks correct to me. So I want to start looking at output files. So I go here at contour details and let's see, I want to look at saturation. Let's say saturation in this case. Okay. When we start looking at output file, I quickly go to contour and change it to flood. And this is how it looks like. You have a model where it shows a saturation of 40% at the edges. The river is above 80% saturated. And in between, it varies like that. Okay, that's good for me. Maybe reverse colors. I want to see more logic to see like fully saturated as blue and dry as red. So something look like that. So I have unsaturated edges of the model. I can flip it to see it better. So before I flip it, I want to make these two models work together. So whenever I change the view here, I want to see the same. Another one, so I go frame linking, and I want to link the 3D plot view, apply and close. And in this case, whenever I move this one, so let's say I want to see the cross section here. Okay, the vertical exaggeration. I want to see the highland and the lowland. So a vertical exaggeration of 1 is not that helpful. So I go back to view, sorry, plot axes, and let's say I make it independent, XY dependent only, and I add a vertical exaggeration of 3 in these cases. So thicker, so you can see the topography of the lands. You have like highlands here, and lowlands in the middle. Let's do the same here. I think because we've linked, it already changed the vertical exaggeration for the OLF domain. So I have here saturation. I can see saturation, okay, is unsaturated. We have a rainfall event. So if I press play, it should go through all the simulation times. It's super quick. So you can go step by step. Okay, if I go step by step, I still can't see anything. Nothing is changing. Okay, I think the problem here is these ranges are super high. It's not giving me the flexibility to see the changes. So you go through, you make sure that you are, oh, sorry. Yeah, my mistake. I was choosing this one and I was playing. So it was playing here, and here I'm showing zones. The zones doesn't change with time. It's like an input file. Sorry about that. So if we choose this zone and start play, you can see the saturation changing. You can see that a rainfall event occurring, and the saturation is going up through the whole domain. And now it should reach top saturation here. So you can see like saturation, the fully saturated part is gaining, and I think we almost got rid of like the red parts and still going up. And you see like this rainfall event stopped somewhere here. And if you flip through the time, you can see that saturation is reducing again. So give you a good indication about like how saturation changed in the model over this rainfall event. Okay, I go to this one and I press details. I want to show also output, not zone anymore. Like I already showed the zone. So I want to see the water depth, how much water accumulated on the surface. It's showing me here like 2 centimeters and 4 centimeters. I don't think that this is enough, so I will set levels. I will start with maybe 1 millimeter, so super dry. And I will go to 4 centimeters, should be enough, and a delta of 1 centimeter. Okay, so I want to see at 1 millimeter, 1 centimeter, 2 centimeters, and 3 centimeters. Close. I make sure that I choose this frame and I go through time. And you can see here that water level is going up with the rainfall event. You start seeing like flow occurring in the stream or like water accumulating in the stream. Same case, I want to go detailed and flip. I want to make the water in red and the dry parts where doesn't have any surface water in red. So sorry, water in blue, and where it has the dry parts is in red. Template. I can go back to frame linking, and I choose solution time. So whenever I choose any one of these and I'm going through solution time, it will show solution time changes in both. I apply to both frames and close. And if I press play here, you'll find both of them are changing. Saturation and water depth. Okay. What if I want to have the exact values of water depth? Looking at the legend is not enough. I want to see how water depth changed over time. I go to tools, prop to create a time series. I want to see the water depth in the middle of the channel. So I come to the middle of the channel and I press a button. And it will create a new frame for me. This is a new frame. It's frame number 3 if you look here. And for frame number 3, it shows the water depth over time. And change the size of it and can look here. So you can see here we started at 0, so it was almost completely dry. We have a rainfall event, and the water level went from 0 to about 5.5 centimeters. And at this time, which is about 3,000 seconds, it started going down. The rainfall event ended and it's drying. So by the end of the simulation, we had a water depth of about 4.5 centimeters. Okay. Sure. And what if I want also to look at a cross section here? I want to see the saturation level here, or I want to see groundwater level at this cross section. So I'll choose this domain. Okay. And you see here how you can draw shapes. I will choose a line, and let's say I want to go from this side to this side. Okay, so I draw a line, go back to arrow, and I choose this line, and I want to extract values at this line, extract points. How many points? The default is 200. I think 200 should be enough for this cross section, so I extract. So what I did was I went to this cross section and I extracted the values at this line. What I want to do is that I want to add one more figure here, like one more time series figure here to show groundwater level. So I'll come here and draw a frame. This is frame number 4. It's a bit tricky with Tecplot is if I want to draw data in this figure, it will always look at the next figure, which is frame 3. So let's say I come here and I want to add an XY data. Sorry, not 2D XY. It's only looking at time series plot zone. It's looking at frame number 3. I don't want frame number 3. I want to look at data from frame number 1. So I want to change the order. So I want to move frame number 1 up and up again. So now when frame 4 is looking for data, it will look for the next frame below it, which is frame number 1. And in this case, oh yeah, I need to recreate this one. Choose XY. Now you can see it looks at what extracted point. It look at the porous media, which is the data already we uploaded from HGS, and extracted point is a new data that we created. Okay, so I'll choose extracted point, and this direction is what is the Y direction, right? So I want to make the X-axis as the Y direction. So across the channel here, so I choose this one as a Y direction. And to look at groundwater levels, I need to draw land surface first. So land surface first is the Z axis. So I want to look at Y versus Z, and I press OK. And you can see this is a cross section. You can see like, okay, it's a bit hard to see. So let's play with this one. So X1 labels, make it a bit bigger, and Y1 labels, make it a bit bigger, and title, make it a bit bigger, and X1 title, make it a bit bigger. Okay, so we're looking here at the Z axis, and the elevation started about 4.2 on this side, went down to about 3 meters. So the elevation of the bottom of the stream is about 3 meters, and it went up to, on this side is about 3.6. So this is the land level. We're gonna go and add water level so we can see how deep is groundwater. So we create a map. The X-axis should be Y, and the Y-axis should be head in this case. Extracted point, okay. Lines. Let's make water level as blue, and let's make the land surface as black. And let's highlight the land surface. Make it even a bit thicker. Okay. Close and plot view data fit. So you can see here that this is how the groundwater level look like. You can see it's flooding here. It's above the soil, is above the land level, because you have like a river here with water moving inside. You can see here, you can confirm it here that you have water in here. So water level is above land surface in the channel and goes below the channel on the side. And this is how deep your groundwater is. And if you can get it, you want to get it in numbers, you can probe. So let's say on the side here, you have a ground level of about 4 meters and water level of about 3.4 meters. So groundwater is about 60 centimeters below land surface in this case. If you check the middle, then you get higher water level because like you have a river here. So the river is about 3.3 with O3, and ground level is 2.99. So you have about 4 centimeters of water above or in the river in this case. Does it match? It should match, like, because like it's should show here about 4 point something. We're not choosing the exact point for both cases, but this is a way of showing your results. Okay. Can modify your figures, make them look better. You can Yeah, actually, if you wanna save all 4 plots as one image, you can go through tools and options and ruler and grid, and you can show paper. Okay, so it will make the whole figure white. And in this case, you can go and file, export, and let's export this one. Let's export all frames. Let's add more width and save this file as our second output. And in this case, it's PM versus OLF. And you can save this file. Okay. Second thing, what if I want to show water level on top of the porous media? And this should be our last thing to do today. So these 2 frames, we have no need for them for now. Okay. And then we want to show here, we want to show on the OLF only water. So how can we show only water? It should be easy. We have value blanking. So we want to show only areas here where it has water on the top. So we go here and press data. Plot blanking, value blanking. Make sure that you are choosing the right frame. I'm here choosing frame 1. So if I'm going to blank, it will be here. Now I'm going to go here and I want to only show water surface. So I want to choose depth and let HGS block blank every place in the OLF domain that has water below 1 centimeter. So all the dry areas in the model, and then press active and active. And you can see here, I'm only showing in this case areas where it has surface water. That's good. Second thing to do is I want to move this frame and put it on top of this one. But to move this frame on top of this one, I have a background here. The background will hide the porous media, so I need to hide the background. So you can see here, you can show the background. I will say no. Show the border. I will say no. Okay, so now I have only areas where it has water and there is nothing to block this part. Okay, I will come to the porous media domain. And in this case, I don't want to show saturation. I want to show land surface. So I will choose Z instead. And I will change the color scale to above ground level. This should be, or elevation absolute. One of these should be good to show elevation colors. I think the above ground is better. Set the level. We can set from 1 to 3 delta of maybe choose number of level, maybe 10 levels. Okay, so we give it like more levels here. Okay, now I want to move this one on top of this one, but if I want to show the water flat, I want to make the z-axis as head. So I go back to plot and assign axes, and x is x, y is y, and z is z. If I want to show the 3D, if I want to show water level as a flat surface, I need to change z to head. And in this case, water surface will be flat, which should look better in a 3D view. The other thing I want to show is that, like, whenever I say OK, the vertical exaggeration will go bad again, and you need to go and adjust it. So if I press OK, vertical exaggeration is blown up. So I want to go back to plot, frame. No, plot Tecplot axes, and sorry, I think I'm getting a bit tired here. Yeah, and range, and I want to change the Z back to 3. I think we chose 3 as our. Okay, let's delete this line. I don't want to show it anymore. Okay, let's move this one here, and let's put the water on top of the ground surface. We do frame linking, and we're gonna do a frame size and position, and apply, close. Now move the depths to a different scale. So you can see here that we have land surface. You can see land surface with land elevation, and we have water surface in the middle. For water, I don't think that this scale is nice. I think what we can do is show it as all blue. Yeah. And when you press play, it can show you how it's a bit quick. So maybe you can do it manually. So you can see the water level going up, flooding and coming out. And maybe we can increase the blue a bit, make it a bit darker. Oh yeah, or maybe reverse. Yeah, okay. So can blade, and you can see water accumulating on the surface and coming out of the mall. And I think this should be enough for the tutorial. You can take this figure out and save it as an animation that you can put in your figure. So you can choose time animation and export it to a file. AVI should be fine. All frames, yes. Width should be okay. Animation speed, you can change the animation speed based on your presentation if you want to show it quick or fast. Let's say I'm gonna do like 1 frame per second and press OK. And I wanna export it as PM versus OLEF, same name as lay file, should be fine. Wanna save it, and I will save a video that I can show how the water accumulate on the surface. Okay, I think this should be enough for today, and let's take questions.
Thanks, Omar. We do have one question in the chat related to observation wells. So how would the graph look like if we have output for different nodes? How do we select a particular node to be shown? So I think it would be a good idea just to go over the utility that you mentioned earlier and how we can reformat the output files from observation wells so that they can be viewed in Tecplot.
Okay. Cool. So yeah, let's go back to block format. So this is how block format look like. It will give you at each certain time, it will give you a bunch of, it will spit a bunch of rows. Each row will represent a certain depth. So in this case, let's say you're choosing 20 nodes, you are getting values at 20 nodes. So you're getting 20 columns at each time. You want to load it to Tecplot, it's not going to read it. It will fail. Previously in Aquanty, we had a utility. I'm not sure if it's still supported or not. You read this file and choose which, you can choose all your depth to show, or you can choose some. Let's say after you run it, you are sure now that your screen should be between like the 5th node and the 7th node. So you fall between these three. So you run the utility, you give it like which nodes you want to show, and it will give you like a time series. It will be time versus node 1, node 2, node 3. And then you can plot it on Tecplot. And in this case, you can show first line, second line, third line. And you can actually in Tecplot do like an average. So you can show one line showing the average value of head within this sequence. We also have a Python code in-house that we use it to, instead of like the utility, use it to read these files and also switch it into a time series for you to plot and Tecplot.
If I can just chime in quickly, I would say probably the simplest way to get around this problem would be to simply assign multiple observation points instead of assigning an observation well that spans across 5 or 10 different nodes. If you're interested in a particular node and you're not exactly sure where that node lies within the range of where your, let's say, your well screen lies, you can assign an observation well. This is going to spit out some coordinate data for you, so you'll be able to identify the exact coordinates of all of the nodes that lie within that range. And then you can simply run grok again, amending the grok file to replace the observation well with multiple observation points. This is also just a very simple workaround to produce a Tecplot formatted output file for all those different points.
Yeah, a small comment to Braden is we have a well domain in HES2. So let's say you have your screen and you want to put an actual screen in HES. So you can add a well domain and then you define the start and end of your screen. And you can add properties for your well. So it will carry like the diameter of your well and the hydraulic, the K around the casing, around the changing K around the casing. And in this case, you can add a node in between and it will capture the whole thickness of your screen. It will represent the whole thickness of the screen. But it's a more sophisticated way if you are very interested in what the well will look like, because it also will transfer water in between layers through this well, which what should happen exactly in a screen inside. Okay.
Now I see somebody else is typing a question. So we can perhaps wait a moment for that. Or George, if you would prefer to just unmute yourself and ask the question, that's also an option.
Okay. So my question is about the commands that you presented to truncate the model. So, because I understand that what you want how can I say, to clip is the 3D view of the model. So the first question is, do these commands go in the grok file? And if they go there, it means that I cannot change that truncated model after I run the simulation?
No, it's actually an Hsplot, so it's a pre-processing command. Okay. So let's see. Yeah. Okay. So it goes here in the plot control. So it's after you run your HES and you wanna turn your HES output into a Tecplot readable file. So it's only working on this portion. You still have your HES output complete, and you only are going to take from HES output for a certain area and process it as a .dat file for Tecplot. But you still can, you still can run again Hsplot for a different area, and you want to only show this area, and then later you are interested in a different area, you have your HES output already for the whole model. It's only for the last step of the model.
And I'll just also mention that the plot control and I believe the output variable control files, they're actually produced when you run Hsplot.exe for the first time. So after you run phgs.exe, the model will produce all possible results, all of the geospatial data, the time series files that you would expect. At that point, if you wanted to immediately truncate the model results, you wouldn't be able to because the plot control file won't be available. So you'll just quickly run hsplot.exe, and then you can immediately terminate hsplot before it finishes. For example, if you have a very, very, very large model and hsplot takes a long time to run, just quickly run hsplot and then quit it. The first thing that happens when hsplot is run is it actually produces this plot control file if it's not already found in the model folder. The other thing that I should point out is that the contents of the plot control file are also dictated by the contents of the model outputs. So if you run a model, so for example, if you run a flow only model, you run Grok, you run PHGS, you run Hsplot, then the plot control file will contain a bunch of information regarding flow variables, but it wouldn't include information about concentrations because at that point, the model is not a solute transport model. If you later go back, add solute transport to your model, you run Grok, you run PHGS, and then you run Hsplot again, you'll notice, how come I'm not seeing concentrations? And that's because the old plot control file is still dictating the type of data that Hsplot will process. So in some cases, if you make changes to the model that introduces new variables, it might be necessary to delete the plot control file and then run Hsplot again so that it produces the new plot control file with all of the variables associated with the updated model.
Okay, thank you. I think it was going to be my second question. Thank you so much.
No problem.
Thanks.
Okay, I'm not seeing any other questions in the chat. We'll maybe give it another couple of seconds if somebody wants to chime in with a question. Going once, going twice, going 3 times, sold. Okay.
Okay.
Omar, thank you very much for taking the time out of your busy day to deliver this training session. It's definitely very, very valuable to the user base. I think as a final comment, I'll just point out that you know, we're always available to answer any questions that might come up or come to mind after the training session. Feel free to send us an email at support@aquanty.com, or you can contact me directly at bmcneil@aquanty.com. I believe I'm in touch with everyone here. Thanks a lot for joining us in today's webinar, and we'll see you at the next one.
Yeah, thanks for coming.